We'll begin this next podcast with an examination of the modern periodic table, now that we understand the history of its development a little bit better. A very important thing for you to do, though, at the end of this podcast is, 1, make sure you watch the videos that I will explain in a future slide, and 2, very important, make sure you take the multiple choice quiz that will be on the Moodle website. It has 10 questions and shouldn't take more than a few minutes to complete and submit. Your deadline to submit this is by 9 o'clock of the following morning that we will meet for a chemistry lecture. Okay, as you look at the modern periodic table, you can see that the numbering can go from Arabic numbers 1 through 18, or a combination of Roman numerals from 1 through 8 with letters A or B behind them. We have, of course, the metalloid staircase. To the right are the nonmetals. To the left are the metals, with the exception of hydrogen, who acts like a metal at times but is not a metal. And of course, the metalloid elements that line that staircase have properties that are intermediate between those of metals and nonmetals. Now, I put a slide in here of what it looks like on the Moodle website. Be sure that you go to Moodle and take a look at these little QuickTime videos. They take 30 seconds to a minute to see. I'll refer to them throughout this podcast, but unfortunately, when I try to embed them in the podcast, the video quality is poor. So it's better to just go to these links and watch them directly. Don't forget, you have a quiz at the end of the podcast as well. Now, our modern periodic table is made up of vertical columns that are referred to either as groups or families. And as you go down a column on this periodic table, of course, the atomic number is going to increase. If you are using the Roman numeral system of naming, each one of those numerals is followed by the letter A or B. For example, group 7 Roman numeral 7A is where chlorine is in. However, you could also just say that's Arabic number 17. The rows on a periodic table are called periods. Remember, the word periodicity means regularly repeating patterns in the physical and chemical properties of the elements. These rows all begin with a metal on the far left and end with a noble gas, except for, of course, the first row, which just has 2 gases, hydrogen and helium. So there are a total of 7 periods, and in between these periods, the properties of the elements change in an orderly progression from left to right. Also, don't forget that the periods, or the rows on the periodic table, correspond to the energy levels of electronic structure. And you will see the patterns that go from left to right across the periodic table repeat every time you get to the last group, group Roman numeral 8A or Arabic number 18. Why does the first period on the periodic table only have 2 elements? You have to go back and remember your electron configuration information. You know that there can only be 2 electrons in the first energy level, and hydrogen has 1, helium has 2. So they only have 1s1 and 1s2 electron configurations, respectively. When you get to the element lithium, which is in the second energy level, it has 3 electrons, so it will put its third electron at the 2s1 sublevel. So lithium is the first element in Roman numeral group 1A, but it's also the first in its row, period 2. Now, the groups often have an A after the designation, and those are referred to as the main group or representative elements because they possess a wide range of chemical and physical properties. We are going to often skip the transition elements, which have the Roman numeral followed by a letter B, because they don't as perfectly show the periodicity trends that we're going to discuss. Now, this is a video that you'll need to view after you finish this podcast. it shows the many forms of vanadium that one can have, which is one of the properties of transition elements. They can have multiple oxidation states. We call those multiple charges, but it means the same thing. It can have many different ways of how it decides to lose electrons. So go watch the video. It's got some pretty colors in it. And I should remind you, you can watch those videos at the end of this podcast, or you can take a break, go back to Moodle and watch them now. Now we've learned that the valence electrons are those electrons in the highest principal energy level. If you are in group 1A, you have all of your outermost electrons ending in something, 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 S1. So you'll only have one outermost electron, and it will be in the s orbital. Atoms in the same group or family have similar chemical properties because they have the same number of valence electrons. They don't have the same total number of electrons, just the same number in that outermost ring. And of course, remember, they don't necessarily just have s electrons. You would have to add the outermost s and p electrons together to get the valence electrons, as we learned in the activity on grouping elements. The periodic table can also be divided into blocks, as we learned in the last chapter, with our S, P, D, and F blocks. And there's no coincidence, even though at the time that the periodic table was originally devised in the 1800s, there's no coincidence that the blocks correspond to the maximum number of electrons that can be held in S, P, D, or F orbitals. And you learn that to be 2, 6, 10, and 14, respectively. Metals make up most of the periodic table, and their properties should be familiar to you. They are shiny or have luster. They are good conductors of heat and electricity. They are malleable, which means they can bend without breaking, and most of them are solids at room temperature, with, of course, the exception of liquid mercury. Another property that metals can have is ductility, or you can say they are ductile. That means they can be stretched into a thin wire without breaking. And most metals have 1, 2, or 3 valence electrons that are easily lost. I would recommend that you watch this video on the metals to reinforce the concepts and be best prepared for the after Vodcast quiz. Metals to the left of that zigzag line of metalloids, metals are to the left of that, except for hydrogen is to the left of the metalloids, way on the far upper left. Even though it's not a metal, sometimes it has properties in which it acts like a metal, so it's in there as an exception. Alkali metals are the first Roman numeral group 1A. They are the most reactive of all metals. If you throw them into water, they react sometimes violently to form alkaline or basic solutions. Definitely watch these videos about the alkali metals. The alkaline earth metals are in Roman numeral group 2A. These metals form compounds with oxygen, such as calcium oxide or barium oxide. You won't generally find alkali or alkaline earth metals free in nature because they're so reactive, and the alkaline earth metals often are combined with oxygens to make oxides. All of the transition elements are metals. And at this point in time, make sure that you watch the video about transition metals, including vanadium. They are divided into 2 subgroups, the lanthanide and the actinide groups. They were also called the rare earth elements because their natural abundance on Earth was less than 0.01%. But another reason why it was hard to find and refine these inner transition or rare earth elements is because they have very similar electron configurations, so it was hard to separate them from each other. So the lanthanides and the actinides together as 2 rows at the bottom are an intersection of the periodic table. We pull them out and put them down there in the F block because if you included them where they would naturally belong, it would make our periodic table twice as long. All of the actinides are radioactive, and none of them beyond uranium will occur in nature. Make sure you take time to watch this vodcast on Glenn Seaborg speaking about the transuranium elements. At this point, I'm going to stop the vodcast number 2. Make sure you go to Moodle and take that 10-question multiple choice quiz. Until next time.